In this video, we're going to talk about probability. Before we define probability, let's define what an experiment, an outcome, and an event are. An experiment is a controlled operation that yields a set of results, and outcomes are possible results of an experiment. So, for instance, a patient taking an experimental drug, what are some of the outcomes? Either it's a favorable reaction, no reaction, or an adverse reaction. Rolling a four-sided die once, well, that could be you roll a 1, a 2, a 3, or a 4. So an event is a sub-collection of outcomes of an experiment. So an example, tossing a coin twice that lands on heads exactly once. Well, that could be what? Heads and then tails, or tails then heads. Notice some of the other scenarios could be head, head, or tails, tails, but it doesn't land on heads exactly once. All right, rolling a die greater than 1 on a four-sided die. Well, that could be 2, or 3, or 4. All right, so there's two types of probability we're going to discuss: empirical probability and theoretical probability. Empirical probability is the number of times an event occurs compared to the number of times the experiment has been performed. So empirical probability is when the experiment occurs and is determined by actual observations. So this can be written as a fraction. So the probability of an event occurring is the number of times event E has occurred divided by the total number of times the experiment has been performed. All right, so a very important survey must be conducted. This has divided families and friends for generations. We're not talking about religion or politics, but we are referring to, that's right, Coke versus Pepsi. So suppose we've done an experiment and these are the results that we've had. There are 5 people that would prefer Coke, 3 people that prefer Pepsi, and 2 would prefer neither. So suppose one person's choice was selected at random. Calculate the following probabilities. So what's the probability that the person's going to like Coke? So the probability of a person likes Coke equals, well, how many people like Coke? That's 5. How many total people were surveyed? Well, add up the total number. 5 plus 3 plus 2, that's 10. So it's 5 over 10. Divide the top and the bottom by 5, and that's 1/2. So the probability that we're going to randomly select a person that likes Coke is 1/2. Okay, part B. Probability that the person likes either Coke or Pepsi. So the probability the person likes Coke or Pepsi is really the same thing as the probability the person likes Coke plus the probability that the person likes Pepsi. So we've already determined the probability of liking Coke, that's 5 over 10. Pepsi, that is 3 over 10. So that's 8 over 10. Divide the top and the bottom by 2. That's 4/5. So when I see the word or, I'm going to take the two probabilities and add them together. All right, part C, the person that doesn't like Pepsi. Now, there's a couple of different options that we can do for this, right? Option 1, if we don't want Pepsi, that could be written like this. Well, the options are the person likes Coke or the person likes neither. If I did that and add them together, that's 5/10 plus 2/10, and that's 7/10. This is fine when there's not a lot of other options that need to be thought about. But option 2 would be the recommendation I would do trying to move forward. Okay, so the probability of not Pepsi can also be written as 1 minus the probability of somebody liking Pepsi. Well, how would that work? That's 1 minus. The probability of people liking Pepsi is 3/10 in this case. I can write 1 is 10 over 10 minus 3/10. That is 7/10. This is what is called taking its complement. We'll talk about the complement more later in this video and in other videos. So note, in order to do a good experiment, you should ask a large number of people your question. The more people you survey, the more accurate your results are going to be. Okay, let's take a look at theoretical probability. This is probability that is determined through a study of possible outcomes that can occur for a given experiment. In theoretical probability, outcomes are equally likely to happen. In our Coke example, there were more people that liked Coke than Pepsi. In theoretical, all outcomes are equally likely to happen. So, I can set up theoretical probability as a fraction also. This is the number of favorable outcomes to E divided by the total number of possible outcomes. So, let's take a look at an example. So, suppose you roll an 8-sided die once. The numbers on the die are 1 through 8. Calculate the following probabilities. So, the probability of rolling a 7. Well, there's only one 7 on an 8-sided die. There's a total of 8 numbers, so the probability of rolling a 7 is 1/8. All right, let's do the probability of rolling a 4, 5, or 8. So we can write, it's an OR, so I'm going to write it as the probability of rolling a 4 plus the probability of rolling a 5 plus the probability of rolling an 8, which is 1/8 plus 1/8 plus 1/8. That's 3/8. Now, you could probably do that in your head, but again, when I see the word OR, I'm going to add. Okay, what's the probability of rolling an even number? Well, that's the same thing as what? The probability of rolling a 2, or the probability of rolling a 4, or the probability of rolling a 6, or the probability of rolling an 8. So I can add 1/8 4 times. That's 4/8, and that's a half. Okay, the probability of not rolling a 2. We're going to use the complement for this. That's the same thing as 1 minus the probability of rolling a 2, which is 1. The probability of rolling a 2 is 1/8. That's 8/8 minus 1/8. That's 7/8. Okay, the probability of rolling a number greater than or equal to 1. Well, that's 1, 2, 3, 4, 5, 6, 7, or 8 at that particular stage. So let me write this out. Well, that's 8 out of 8, which is 1. So that seems guaranteed to happen. The probability of rolling a 0, well, there is no 0 on an 8-sided die, so that's 0 divided by 8. And of course, I can simplify that to be 0. So that doesn't seem like that will ever happen with this die. So some probability facts. The probability an event will occur will be greater than or equal to 0 and less than or equal to 1. That comes from part F and part E for this. If an event can occur, then the probability is 0. If an event is certain to happen, that probability is 1. And the sum of all possible outcomes is 1. So for an example, an 8-sided die, each number 1 through 8 has a probability of it being 1/8. So what does that mean? I could take 1/8 and add it 8 times. That's 8 over 8, that's 1. If I did a coin, half for heads plus half for tails would be 2 over 2, which is 1. Okay, let's take a look at the next example. So the staff of nurses and doctors at Kingville Hospital is shown with the table below. Suppose one person is chosen at random. Calculate the following probabilities. So what's the probability we're going to select a male physician? Well, before we do that, let's add up all the possible people. So I'm going to take 1 plus 10 plus 14 plus 5, and that's 30. So the probability of a male physician, well, how many male physicians are there? There are 14 out of 30. Divide the top and the bottom by 2. That's going to be 7 over 15. A male, well, that's either going to be a male nurse or a male physician. 1 plus 14, that's 15 over 30. Divide top and bottom by 15, that's 1/2. And not a physician, that's going to be the same thing as 1 minus the probability of a physician. Again, I'm going to use what's called the complement. 1 minus. How many total physicians are there? 14 plus 5, that's 19 over 30. I can rewrite this. And my answer here is 11 over 30. Okay, the last couple of examples are going to be dealing with playing cards. So I've laid out the playing cards here. So again, we have the clubs, which are usually considered black, and there's 13 of them. The next symbol there is diamonds. Usually they are red. There's 13 of them. The next is hearts. That's usually red. We've got 13. And the last one is spades. They are black. And there's 13. Add 13, 13, 13, and 13 together, you get 52. Okay, so let's answer some probability questions. What's the probability of a 6 of clubs? So, writing that out. There is 1 6 of clubs, which is here, out of a total of 52 cards. All right, a red 2. Now, there's going to be 2 red 2s, the 2 of diamonds and the 2 of hearts. So that's 2 out of 52. Divide top and bottom by 2. I get 1 out of 26. Notice I changed the bottom to 52 here. Okay, a 4, 6, or 7. That's the probability. Remember, that's an OR, so that's going to be the probability of 4 plus a probability of 6 plus a probability of 7. Well, there's 4 4s. There are 4 6s. And there are 4 7s. That's 12 out of 52 when I add them together. Divide the top and the bottom by 4. That's going to be 3 out of 13. The probability of not an ace, again, I'm going to use the complement. That's 1 minus the probability of selecting an ace. There's 4 aces. I can rewrite 1 as 52 over 52. Subtract, that's 48 out of 52. Divide the top and the bottom by 4. That's 12 over 13. And the probability of a heart, well, there are 13 hearts out of a total of 52. I can divide the top and the bottom by 13 and get 1/4.